Okay, so we want to prove that differentiation is a linear transformation from P4 to P3. Okay? Well, first of all, if you, what's P4? It's a set of polynomials of degree 4. Like something times x squared plus something times x cubed, or x cubed, x to the fourth plus something times x cubed plus something times x squared and so forth, right? If you take the derivative of that, what do you get? Sorry? Yeah, you get a polynomial of degree 3. Assuming you start with a degree 4, that something times your x to the fourth is not 0. I mean, you could get a polynomial of lesser degree. Because in P4, you also, it doesn't include just polynomials that actually have degree 4. It's degree 4 or less, right? But if you take the derivative of any polynomial of degree 4 or less, you're going to get a polynomial, again, degree will be 3 or less. So that's, you got to establish that. You got to establish that it's well defined. Okay, that the mapping is well defined. But once you've established that, we have to just show the properties of linearity, right? Which means then, using the prime for the derivative, the transformation of P of V1 plus V2 is the derivative of V1 plus V2. What's the derivative of V1? V1 and V2 are both polynomials, okay? So we say V1, V2 are members of the space P4, right? Meaning that they're polynomials of degree 4. Okay? So when you see a V with an arrow over it, you think of arrows in 4-dimensional space, 3-dimensional space, whatever. That's not what these are. These are polynomials. Okay? It turns out that this space is isomorphic to R5, but we don't know what isomorphic means yet. Okay? So I can't use that. Okay. V1 plus V2 prime. Okay, we understand that the transformation then of any vector is the derivative of that vector, the transform value. Okay? Well, what do you know about V1 plus V2 prime? If I ask you to find the derivative of e to the x plus the cosine of x, how are you going to do that? You know how to get the derivative of the cosine of x?
Yeah.
You know how to get the derivative of e to the x? So how do you get the derivative of e to the x plus cosine x?
Take the derivative each.
And add them, because that's a property of derivatives. If you take the derivative of the sum of two functions, you get the sum of the derivatives. So kind of the derivative operator sort of distributes over addition. Okay? So, that's V1 prime plus V2 prime, right? Okay? And, okay, in terms of transformation, well, V1 prime is just T of V1 plus T of V2. That's it. So the first property is shown. The second property T of V1 equals C times V1 prime, the derivative of C times V1, right? V1 is just a function. So what do the properties of derivatives tell you about that? Well, that's just constant multiple. You got the constant multiple rule. You even call it that, don't you? Oh, okay. So you're familiar with it. Okay? Make sense? Okay.